Okay, so let's discuss about the first transformation covered in the syllabus. Okay, we are talking about the translation of graph in this video. Okay, so for translation of graph, right, means that we are going to move the whole graph, right, either going up, going down, to the left or to the right. Okay, so we call it as translation. So the keyword will be translation, or you can write it as shift or move. Okay, so for the translation of graph, right, basically we need to see in what direction the graph is translated, right? So first, if we are having a plus a outside the basic function, for the fx here, I will call it as a basic function or the basic curve. Okay, so this is a basic function or basic curve, and then if you can see that we are trying to add a number outside the basic curve, or minus the number outside the basic curve, right? Then generally we are talking as a translation of graph in y direction. Okay, so when you're having something plus a number or minus a number outside the basic curve, then it is actually a translation of the curve by up-down translation. We call it as up-down translation or translation in y-axis. Oh, sorry, I need to write it here. Or you can write as translation in y direction. Okay, so what is the how many unit that we try to translate our graph? It depends on the value of the a. As an example, if I'm having plus 3, so that means we are moving the graph are 3 units going upwards, plus 3. If let's say I'm having the value of a, which is -5, if it is a negative value like -5, that means that we are moving our graph 5 units downwards. Alright? Okay, then when we want to put it in this translation, right, in the general equation or whatsoever, then we are writing it. You can write it in this way, by the vector 0a. So the value on top here means the translation in the x-axis or x direction. Then the bottom one will be the y direction. Since we're having a plus a outside the basic function, right, so it is a translation in y direction. Therefore, when we want to put the value in the vector, right, you put it in the y, the value for the y at here, which is at the bottom of the bracket. Okay, all right. So if let's say I'm having a plus a here, then in the vector part we're going to put 3 plus, this is plus 3, then we are going to put plus 3 here. If let's say this value is -5, then we'll put a -5 here as well. And again, the keyword that we must explain in exam, right, to answer the question what kind of transformation that we have, you must tell them clearly what is the value being translated and what's the direction. So for the direction, it can be up, it can be down, alright, or you can be moving upward or downwards. So all the direction and also the value must be shown when you're trying to explain or describe, okay, the direction or the transformation involved in the question. Okay, then now we're going to the next one. If let's say we're having a minus a, you can see that the negative a or positive a is inside the basic function. Okay, so it's inside the basic function. You can see that the negative a is inside the function fx. Then generally it is actually the horizontal translation. So you can call it as left-right translation. Okay, or you can write it as the translation in x-axis. Or in x direction. Alright, okay, so this is the horizontal translation and the top one will be the vertical translation. Okay, and then you have to take note on the vector for the horizontal translation. When I'm having x minus 3, okay, in the general, in the function form of the horizontal translation, when you want to put it in the vector, then -3 here will become a +3 in the vector for the position of x. Alright, it is because of when we're having the negative a or positive a inside the basic function, it is something like we are having x minus a equals to 0, and then the units that we shift the function is actually x equals to a. Alright, so as an example, if I'm having y equals to x squared, and then if I want to put it as, if I have a translation, okay, outside the basic function like x squared plus 4. So you can see that the plus 4 is actually outside the x squared, right? So it is the up-down translation. For this case, it is going up. Alright, plus 4 are positive, so it is going up. And when I want to put it inside the vector form, it will be a vector of 0, 4. Okay, for your understanding on this part. And then as an example, if let's say I'm having y equals to x squared, and if I'm having the translation like this, y equals to x minus 4 squared, you can see that the negative 4 is inside the square. That means it is inside the basic function. Alright, so this is a horizontal translation. Okay, so for horizontal translation here, right, if I want to put it in the vector form, because inside the function is negative 4, so when I want to write out in the vector form, it will be 4, 0. And when I'm having 4, 0, we are moving this in right to the right, 4 units to the right. Okay, so for 0, 4, we are moving it 4 units up. Then this one, we are doing it 4 units to the right hand side. Although when you look at it, it is x minus 4. So for the translation in x direction, it is always opposite. When you're having negative 4 inside the basic function, basically it means that you are moving it 4 units to the right. Okay, so another example, if let's say I'm having y equals to x squared also, but if I try to have a translation like this, x plus 5 squared. Okay, so when you see that it is x plus 5, the plus 5 is inside the square. When you want to write in the vector form, then it will be negative 5 and 0. So please take note, this is plus 5 inside the basic function. When you want to move it out, it will become x equals to negative 5. Therefore, the vector in the vector part here, the x value will be negative 5 and 0. So when you're seeing negative 5, it means what? It means that you are moving your graph 5 units to the left. Alright, so that's why besides writing out the value itself, we also need to write out the direction so that it is clearly explained. Alright, how are you going to move the graph? Okay, in how many units? So make sure you include the value, how many units you move the graph, and also with the correct direction. Okay, so we are having the vertical vertical translation, and also the horizontal translation. Okay, and after that in our syllabus also they actually will combine the translation in both directions. So as an example, y equals to fx minus a plus b. So this one means that you are having both translation in x direction and also the y direction. If you put it in the vector form, there will be translation a for x unit and also b for y. Okay, a unit for x and also b units for y. And again, if you want to explain the translation, please make sure you include both value here with the correct direction that the graph is translated. Okay, so this is a general idea on the translation of graph. Let's have a look for a few examples so that you roughly know, okay, how are we going to answer the question that is related to the translation part. Okay, let's have a look for the example 2 in our notes. Okay, so I think I need more space here. Okay, so for example 2, they are saying that fx equals to x squared. That means my basic function is x squared. They want us to sketch the following graph on the same axis. Okay, so there are 3 graphs here. Y equals to fx minus 4, y equals to x minus 2, and then y equals to x plus 4 plus 3. Alright, since I know that my basic function is this one, y equals to x squared. Okay, so if I want to sketch my very basic graph on y equals to x squared, I will just simply draw it. Just sketch it, alright? This is my basic function. Y equals to x squared, and I know that the basic shape of the x squared will be the U shape, right? And then if possible, in exam, when you want to sketch the diagram, please make sure that you sketch it symmetrically. Okay, so my one cannot be very symmetrical. So I hope that you all understand that this is actually a U shape. And then this is the basic curve where y equals to x squared. Okay, so let's have a look for the first example, part A. They are saying that y equals to fx minus 4. So you can see very clearly that the minus 4 is outside the basic function, where if I write out, it will be y equals to x squared minus 4. So the minus 4 is outside the x squared, outside the basic function. It means that this is the vertical translation. Vertical translation means that either you move it up or down. And since we are having the value negative 4, that means that we are moving the whole graph 4 units downwards. If you move it 4 units downwards, right, the original point here is 0 and 0. So if you move it 4 units downward, then the 0, the y coordinate will become negative 4. So I can have a graph like this. Okay, so I know that I'm going to move my whole graph 4 units downwards. I think better if I can try to copy. Okay, so that means I'm moving my graph 4 units downwards, so it should be something like this. So you can see that basically the shape of the curve is still the same, which is actually the U shape. Okay, just that the minimum point here, the minimum value here, we change it from 0 to negative 4. So this green color graph basically is y equals to x squared minus 4, where we are trying to move the y equals to x squared 4 units downwards. Okay, so this is what you can see, okay, from what we have here. So we are moving the red color graph 4 units downward, become the green color graph. Okay, then of course, if the question requests, then you can further investigate and see what is the x coordinate or x intercept for this particular curve if you want. All right. Okay, then next one for part B. How are we going to sketch the graph for part B where y equals to fx minus 2? If you try to write this in the function pattern, so I'm having x minus 2. The negative 2 is inside the basic function, so I'm having x minus 2, that only I square it. When the negative 2 is inside the basic function, right, that means what? That means that we are having horizontal translation. So for horizontal translation, you need to decide whether this one is going to the left or going to the right. So like what I mentioned earlier, when I'm having x minus 2 inside, this is inside the basic function, right? You assume that it is equals to 0. That means you are going to move the x, the graph, in x direction for 2 units. That means going to move it to the right hand side for 2 units. Okay, so if I want to move it 2 units to the right hand side, then you can label this is basically the 2. And then if I try to sketch on my diagram, will look something like this. It is still U shape. Okay, it is still U shape, but I'm trying to move the whole U shape or whole U curve to the right hand side, which is 2 units. And then this purple color graph will be y equals to x minus 2 squared. Okay, so this is what you have for part B. And let's have a look for part C now. Okay, so for part C, they are looking for this, where y equals to fx plus 4 plus 3. So the plus 4 is inside the basic function, plus 3 is outside the basic function. So from here, you can see that the translation involved is actually in both directions, both x and y direction. And you can see that if I try to put it or write it out in the basic function form, I'm having x plus 4 and then only I square it, and the plus 3 is outside the whole function here. Okay, so this function, when you look at it, you know that this part, it involves the horizontal translation, and the plus 3 outside the basic function means the vertical translation. Okay, and then please take note also, when you're trying to write out in this pattern, right, this is actually a completed square form for a quadratic equation. Right, for a quadratic equation, which means that when you want to know how the quadratic curve is translated, right, if you can change it become a completed square form, then you can see very clearly how a quadratic curve is transformed or is translated, is shift. Okay, all right, yeah, so from here, I know that the plus 4 here means that I'm going to move my graph 4 units to the left. Okay, and then the plus 3 means that I'm moving it 3 units up. Okay, so that means from my original curve, which is the red color curve, using the original point 0, 0, move 4 units to the right hand side, maybe it is somewhere here, and then move up 3 units, then maybe it will be somewhere here also. Okay, so let me draw it out now. 4 and negative 3, I assume 4 and 3, so I assume that this is negative 4, 4 units to the left, and also the 3. So maybe this one is what we have. Okay, this is a negative 4, and then this is actually a 3. So for this particular curve, it is actually y equals to x plus 4 square, then plus 3. Okay, alright. So this is how we actually try to sketch the diagram when the translation is involved. So we have vertical translation, we have the horizontal translation, and also the combination of both vertical and horizontal translation. Okay, then for a quadratic curve, if you can rephrase it in the completed square form, it will show you clearly how the original quadratic curve is translated. Alright, if you put it in a completed square form. Okay, alright, and then now, after we know how to sketch all the graph also, okay, let's try to describe, okay, the transformation in sentence. Okay, so I will just take all this as example. Okay, so for part A, if I have something like this, so when I want to explain or describe the transformation involved, then basically you can write in this way. So you can write it like this. The graph is translated okay, so 4 units upwards. Okay, this is one way of writing out the description for the translation. Right, so from the sentence here, you can see that I mentioned clearly how many units the graph is being moved or translated, and also what is the direction. So the upward is the direction, and then the 4 is the unit. Okay, or you can write it like this: the graph is translated with vector 0, 4. Okay, so this is another way of writing out the description where, okay, the 4 here means that it is in y direction. So positive 4 means moving up. So automatically we actually know that, oh, it is a positive 4, so it means moving up. Okay, then 0 means that in horizontal direction, which means that we didn't move it at all for the value 0. Okay, so there are a few ways for you to write out. So you can either write out in like this or like this. Okay, so any way will be accepted. Okay, right, but just always bear in mind when you want to describe anything, please make sure that you include the units involved and also the direction involved. Okay, then for this kind of transformation, because we are talking about translation, right? So you can see that translate is another keyword as well, because later we have other type of transformation. So the particular transformation, what is the name for the particular transformation, you also need to mention in your answer. Okay, all right, so let's have a look for maybe for part B. Okay, let's say for part B, if I want to describe this kind of translation, how can we do that? So you can write it in this way: the graph is translated. Okay, so for this one, because I'm having 2 units to the right, so you can write 2 units to the right. Okay, this is one way of writing it out. Or you can write it something like this: the graph is translated with vector 2, 0. So again, this is a 2. When you're having negative 2 here, when you want to write out in a vector form, it will be 2, 0. So the positive 2 here means that it is understand that the 2 units for x-axis, which is in horizontal direction, positive value means going to the right. Okay, so when you write out in a vector form, right, it actually explains everything clearly. All right, it is in x direction, then 2 units to the right hand side. Okay, all right, then last one, how about for part C? So for part C, if you want to describe it in sentence, so you can write: the graph is translated 4 units to the left and 3 units upwards. Or you can write it in a simple way in vector form. The graph is translated with vector, then you're having -4 and 3. Alright, okay, so this is one example to show you, right, how are we going to sketch the translated graph, how to interpret the formula after translation, and also how to write it out in a sentence, how to describe the correct translation in sentence. Okay, so this is what you have for example 2. Maybe you can proceed to example 3. Okay, so for example 3 and 4, they are more exam style, more exam-like question. Okay, so let's have a look for example 3. So for this example 3, it is taken out from the specimen paper of year 2020, paper 1, question number 5A. So they give us a curve. This is the original curve, and then they said it is translated by 20. So find and simplify the equation of the translated curve. Okay, so for this kind of question, originally we are having fx. Okay, and now they actually want us to find out the translated curve. We know that it is translated by this vector 20. So for 20, it means that the 2 here is at x, right? The x position. So that means it is actually the horizontal translation. So when you want to convert it into the function form, it is actually x minus 2. Okay, so please take note that it is not positive 2, but it should be x minus 2 when you want to write it and put it inside the basic function. Okay, so my original function is fx, where the formula is x squared plus 3x plus 4. And now I want to find out the translated curve, where it should be fx minus 2. So how can we simplify it? That means we have to substitute all the x by using x minus 2 now. So I'm having x minus 2 squared plus 3 times x minus 2 and then plus 4. Try to expand and simplify it. So expand everything. So you have expand this square, x minus 2 squared, and then multiply in the 3 and simplify. So end up you will have x squared minus x plus 2 as the answer. So this is the simplified equation for function fx minus 2. That means after the translation, the equation will be this equation. Okay, so this is how we try to rewrite. That means we are doing it in the reverse way. They tell us what is the translation, and then we are going to find out the function. Okay, so this is one kind of question that might be asked in the exam. Example 3. Okay, then proceed to example 4. Okay, so for example 4, they give us 3 different functions here, f, g, and h, and all these can be seen like this. Okay, so for part number 1, they want us to express this equation, this expression, which is gx. You can see that it is actually gx into this form, x plus a squared plus b. And then a and b must be the integer. Okay, so let us start. So this pattern basically means the completed square form, right? The complete square form for quadratic equation. So this is my original expression here. So to complete square, I copy the first 2 terms in the quadratic equation, and then I need to plus something square and minus something square, right? So what's the plus something square and minus something square here? The something can be decided by using the value 6 divided by 2, which is a 3. Okay, so we learned this already in chapter 1, so you might go and revise it again if you already forget how to do the completed square form. And then the plus 4, I just copy back the plus 4. Okay, so I combine the first 3 terms, become one big bracket with a square outside. Then I'm having minus 9 plus 4. And from here, if I further simplify it, I'm having x plus 3 squared, then minus 5. So this is what we have for the first part, where they test us on the completed square form. Okay, so this is not hard because we already learned it from chapter 1. Okay, then continue further for part number 2. They want us to describe fully the sequence of transformation from f to g. Okay, so my function fx is x squared, which is a basic one, and my function g is this one. And they want us to describe the transformation. Okay, alright, so just to write out for you, fx is this one. And then we are going to transform it become x plus 3 square, then minus 5. So from here you can see that it is actually a translation that involves both the x and y direction. Okay, so like what I mentioned earlier, if you want to describe it, you can write in this way. You can write like translation, or the fx is translated with a vector. Okay, so plus 3 inside the basic function, when you want to write out in the vector, it should be negative 3. Then minus 5 here. Okay, the minus 5 here, you just copy, because it is outside the basic function, so you just copy the value itself. So you're having with vector negative 3, 5, or negative 5. Okay, so another way you want to describe can be fx is translated, okay, 3 units to the left and also 5 units downwards also can. Alright, so there are two ways for you to writing out the to describe, okay, the sequence of transformation. Alright, so for me, I will just write it like this in a vector form. To me, I think this is more convenient, okay, and easier. Alright, then let's have a look for part number 3. Okay, so for part number 3, on the same axis, they want us to sketch the graph for y equals to gx and also y equal to hx. Okay, so maybe for me, I will try to put in y equals to the gx first. So for gx, right, we already write out the equation just now where it is x plus 3 square minus 5. And then for hx, if you look at the question, right, okay, it is x squared plus 8x plus 11. It is very hard for us to compare these two functions if we want to sketch it out. So the easier way will be, we will try to also complete the square for hx. Okay, so for this one, we are having plus 4 square, then minus 4 square, and also plus 11. Okay, so when I try to simplify the equation, I'm having x plus 4, and then square with minus 5. Okay, so now we can try to compare gx and also hx. You can see that these two functions, right, basically the value here is the same. The only difference is the plus 3 and plus 4 here. That means what? That means both minimum value for gx and hx are the same, which is negative 5. So they are only have the difference in the horizontal direction, where one is x plus 3 squared, another one is x plus 4 squared. Okay, so how are we going to sketch the diagram for gx and hx? Okay, so we'll draw it in this way. So for the gx, right, it should be a U shape, okay, because the value in front of the x squared here is a positive value, so it should be in a U shape. And then I'm trying to move the original U shape, 3 units to the left, 5 units downwards. So that means my gx might be somewhere here. 3 units to the left, let's say this is a negative 3, and then 5 units downwards, so maybe this is negative 5. Okay, because of just trying to sketch a basic graph, so I didn't go and figure out what is the x and y intercept. Okay, so I just try to draw a very basic U shape. Okay, so this is gx. And then if I look at hx, I'm having x plus 4 square minus 5. So that means from the original x square graph, I try to move it 4 units to the left, 5 units downwards. If you try to compare it with gx, right, basically their minimum point is the same, which is negative 5. But you need to know that this value is basically negative 4. They are 1 unit apart from each other to the left or right. Okay, so if you want to sketch the diagram, it is still the same U shape, but the graph might look something like this. So again, this is just a sketch of the graph, and I didn't go and figure out what is their x-intercept and y-intercept. But I just want to show clearly that each of them are 1 unit to the left or right for each other. Okay, so you label clearly, the red color one is the gx, and also the purple color one will be the hx. Alright, so if you are interested to know more detail about the diagram, then you can try to figure out the x-axis, the x-intercept, so that you can sketch the diagram more accurate. Alright, so for me, when I discuss it here, I'm not going to show it to you. Okay, I will just show you roughly the idea. Alright, what is the difference between these two? So you can see that minimum value are the same, at the same height, and then they are just 1 unit apart, okay, to the left and right for each other. Alright, then how about the last part here, part number 4? They want us to describe fully the transformation that map from G to H. Okay, so again, what is my G? G is the red color one, x plus 3 square minus 5. And then we are going to map it to the H. So the H function is x plus 4 square minus 5. If you have a look for the diagram that we sketched just now, I think it's quite clear lah. From red color to the purple color, that means we are moving it 1 unit to the left. Okay, so 1 unit to the left, which means that if you want to describe it clearly, then your description can be something like this. It is actually a translation, okay, with the vector 1 unit to the left only, right? So you can write -1, 0. So the -1 tells you that the direction is the left direction. Okay, 1 means you are moving it 1 unit to the left hand side lah. Okay, or you can also write it in the longer sentence where it is a translation, okay, with 1 unit to the left, also no problem. Alright, okay, so these are a few examples that the question might ask in the exam. Okay, so please make sure that for this transformation, we're talking about translation, right? Okay, please make sure you know how to observe them correctly in which direction. That's the first thing. And the second thing is please make sure that you know how to explain or describe them correctly. Alright, okay, so this is what I want to discuss for the first kind of transformation that we have here, which is translation. So we'll continue to discover some other type of transformation in the next few videos.